Congratulations, you finished your quiz. Now you get to start learning. So what we're gonna look at in this video is a start to factoring bigger polynomials. So polynomials with higher degrees that are larger that you can't just factor with the like box method that you're used to. So we're gonna look at what's called Descartes' rule of signs. We're gonna look at the first two steps today. We'll learn the second two steps when we come back to class, Monday. Okay, so one of the steps that we're gonna look at is listing out all of the possible roots, okay? Because when we're gonna factor this, I don't wanna have to deal with all the numbers ever. I wanna look at a select few. So the way we do that is by listing out P over Q. P is the factors of the constant term in your equation. Q is the factors of the leading coefficient. So for number 1, 12 is P, and right here 1, right, imaginary 1, is Q. Let's sister zoom in. Okay, so if I'm gonna list out the factors of P and Q, we need the positive and negative. So it's gonna be plus or minus P over Q. Okay, so since P is 12, Q is 1, now we're listing the factors. The factors of 12, 1, 2, 3, 4, 6, and 12 over the factors of 1 are 1. So now what you would do is you would write positive or negative. I'm going to use parentheses, so I have to keep writing plus or minus every single time. And I'm going to write my fractions, 1 over 1, 2 over 1, 3 over 1. Okay, well I don't have to write it over 1. We just know that's the whole number. So I'm going to rewrite my answers. So 1 over 1 is 1, 2 over 1 is 2, 3 over 1 is 3, you get it. So there's 1, 2, 3, 4, 5, 6 different numbers. However, there's 12 possibilities because remember we have the positive and negative of each. So next week when we go to factor this polynomial, these are only options. Cool, let's do another one. Okay, number 2, here's P, here's Q. So let's do plus or minus P over Q, so that's 6 over 4. Let's list out the roots. So the roots of 6, the factors of 6. 1, 2, 3, and 6. Factors of 4 are 1, 2, and 4. So now try my answer. I need plus and minus of each of them. So let's start with the over 1. So 1 over 1, 2 over 1, 3 over 1, 6 over 1. So that's 1, 2, 3, and 6. Now I need to put them all over 2. So 1 over 2. 2 over 2 is 1. We already wrote it, so we don't have to write it again. 3 over 2. 6 over 2 is 3. I don't have to write it again. So let's go on to 4. 1 over 4. 2 over 4 is 1/2. I need 3 over 4. And then 6 over 4 is 3 over 2. I already wrote it. So here's all of my options for when I want to factor this guy. Okay, let's do one more. But I think you get it. So P, Q, 9 over 1. Ignore the signs. I know it's negative, but we're just listing out factors of 9 because, I mean, our answer is positive or negative anyways. So 1, 3, 9. So it's all over 1. It's just those whole numbers, 1, 3, 9. But remember, there's not 3 options, there's 6 options because you have the positive or negatives of each. Okay, so that's gonna be one of the steps when we go to factor. List out all of your possibilities so you don't have to sit there and guess and check everything. What we're gonna look at now is the type of roots. We're gonna create what's called a Pni chart. A Pni chart stands for positive, negative, or imaginary roots, okay? We're gonna create this chart because say you are looking at this polynomial and after you create the Pni chart, you realize there are no negative roots. That means when we go to test some of these roots, we're not going to test any of the negative because I already know there aren't any. So let's look at the next page. And I'm going to show you how to create a Pni chart. Hello, sister focus. Okay, so first, the way you write Pni. You literally just go P-N-I. Okay. Wow, really cute. First, the way you get how many positives is you take the equation that you're given and count how many times the sign changes. So I'm going to count positive to negative, negative to positive, positive to positive, that didn't change. So since it changed twice, I'm going to put a 2 in the positive column. Now I have to go back to my equation, and everywhere I see an x, I'm going to plug in a negative x, okay? So if you plug in negative x cubed, that stays negative, so this will turn into negative 3x cubed. If you plug in negative into a squared, it turns positive, so this will stay minus 2x squared. If I plug in a negative here, that turns the sign negative. And there's our negative equation. Now, a trick to remembering, if the exponent is odd, it's going to change. So if it's positive, it's going to turn negative. If it was negative, it's going to turn positive. If the exponent's even, it's going to stay the same. Here's an odd exponent, so that changed. This one didn't even have an x, so it stayed the same. So now I need to count those. So negative to negative, negative to negative. Oh, here's a change, negative to positive. That means there's one negative root. Your whole row has to add up to the highest exponent. So ours here is 3. 2 plus 1 is already 3, so my imaginary roots are going to be 0. Your imaginary column is kind of like just your junk column for whatever numbers you need to equal the highest exponent. To get the next row, you always subtract by 2. We subtract by 2 because imaginary numbers come in pairs. So I'm going to start with the positive, subtract 2, you get 0. Leave negative the same, we're just working with positive right now. And I need this row to equal 3, so I'm going to put a 2. Okay, now that I've subtracted from positive, I'm going to go back up here and subtract from negative. Well, 1 minus 2 is negative 1. I can't have a negative 1 amount of roots, so this is my answer. This is the Pni chart. What this means is when you go to factor, you are either going to have 2 positive roots and a negative root, or you could have 1 negative root and 2 imaginary roots. It's also a way that you can just check your answer at the end. Let's do another one. Okay, let me write Pni here. Okay, let's count positive first. So count the sign changes. Here, here, and that one's good. So 2 positive. We gotta write our negative equation. So remember, even stays the same, odd changes. This is even, it'll stay the same. This is even, it'll stay the same. This is odd, so it's gonna change. And that doesn't have an x, so it'll stay. So count here, positive to negative, negative to negative, negative to positive. So negative also has 2. The whole row has to equal the highest exponent, which is 4. Whoa, it already equals 4. So that's just gonna be 0. Okay, so remember the first step is subtract 2 from positive. So positive minus 2 is 0. Bring down the negative, has to equal 4. I brought down the negative because the first step is just subtract from positive. Okay, now that I've subtracted from positive, now I can do negative. So I'm going to bring down the positive. You always refer back to the first row. So I brought down positive, subtract from negative, so minus 2, and the whole row has to equal 4. Since we could subtract from positive and you can subtract from negative, the last step is to subtract from both. So again, going back up to that first row, subtract from positive, 0, subtract from negative, 0. The whole thing has to add up to 4. So there's the Pni chart this time. So let's make a note real quick. Your steps. You're always subtracting 2. First, you're going to do the positives, then negatives, and then both. Okay, so let's try that one more time, where you can subtract from both. Pni chart. P, N, I. So let's count positives. So positive to negative, negative to negative, negative to positive. That's 2. I'm going to take a shortcut here. Instead of rewriting the whole equation, I'm just going to write whether it's positive or negative. Remember, even stay the same, positive changes. This is even, so it's going to stay positive. This is odd, so it's going to change to positive. Even, stay negative. Odd, change, nothing, stay the same. So now when I go to count, that's here and here. So negative is also 2. The whole row has to add up to that highest exponent, 4. So that's their 0. First step, subtract from positive. So minus 2, bring negative down, has to equal 4. Okay, bring positive down, subtract from negative, whole row has to equal 4. Since I did both, the last step is to do both at the same time. Minus 2 has to equal 4. Okay, let me show you one more little tricky way. P and I. Okay, let me count the positives. So here, 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 and here. Whoa, it changed every time. That's 1, 2, 3, 4, 5. So positive is already 5. I can already kind of tell these both are going to be 0 because it has to equal 5, but I'm going to check my work just in case. Odd changes, even stays the same. Odd changes, even stays the same. Odd changes, nothing stays the same. So these are all negatives, so there is no change. So that's why negative gets the 0. Whole row has to equal to 5, so 0. Okay, now we're going to start our process. First, subtract from positive. 5 minus 2 is 3. Bring down the negative. The whole row has to equal 5, so 2. Now, I can subtract from positive again. Since I can, I'm going to do it again. 3 minus 2 is 1. Bring down the negative. Whole row has to equal 5. My next step would be now, okay, subtract from negative. But negative is already 0. I can't subtract 2 because I can't get a negative number. So this is my answer. And that's how you do P and I. I want y'all to try on these 4 down here and submit your work on Schoology. We'll review this again next week. Have a good weekend.